you're at your speed or you must maybe need some more.
Yes, it's sensitive.
Okay. On page 73, what question is that? 4?
4.
Alright. I need to explain this to you. If you are traveling, let's say you're traveling, I don't care, on a train. And the train's going 10 meters per second. Okay? And you drop something off the train. You drop a box off the train, whatever it is. Okay? So you're traveling 10 meters per second and you drop that box. Is that box going to go straight down from where you dropped it?
No.
No? Which way is it going to go?
The way
You're going.
It's going to go in the direction that I'm traveling. Okay? So, as I'm moving in this direction, I drop that box. It's going to move in the direction that you are traveling. Alright? So, if I'm running in a direction and I throw a ball. So I'm running in this direction and I throw a ball. Is that ball going to move straight in the direction that I have thrown it?
No.
No. It's got to take the speed at which it's also moving. Now, I'm in a balloon. Okay? So a hot air balloon. And I'm moving downwards in this hot air balloon and I drop an object. Does that object start at 0 meters per second? No. What is it?
Dropping it.
It has to go at the speed that I am dropping in the balloon with. You understand what I'm saying? Okay? So, in that particular question, my initial velocity is 4 meters per second. It's as if I was standing on top of the building, on top of the high school, and I threw a ball down at 4 meters per second. It would be the same as me moving downwards and dropping an object as I'm moving downwards. Okay? So the initial velocity then is 4 meters per second that bottle or whatever it is. What is it? What are we dropping?
An object.
Just an object. So I'm dropping that object and I'm moving at 4 meters per second. So what is the acceleration then working on that object that I dropped?
9.8.
So it's 9.8 meters per second squared is the acceleration on it. Now how high above the ground was I when I dropped it?
You don't know.
What is the other piece of information
Lands on the
there?
ground 10 seconds later.
Drops to the ground 10 seconds later?
Yeah.
Hits the ground 10 seconds later. So what do I have right there? I have my initial velocity that I dropped an object. Now normally when I drop an object, there is no initial motion. So if I drop this pen right now, the initial speed of it is 0. However, I'm in something that's moving and then I drop it. So it has to take it as a positive direction. Now, if that balloon was moving upwards and I dropped that object, how does that change the question?
V1 would be negative.
My V1 would be negative. My acceleration is still positive because it's going to increase in its speed. Now remember, I mentioned this yesterday. This is not how the book does the question. The book says that if you were moving, if the object's moving downwards, I'm going to have a negative acceleration because that's down. I don't want to do it like that. I want to always remember that if the object is going to speed up, so if I drop it, is acceleration going to increase the speed of it, or is it going to decrease the speed of it? If it's moving down, is the speed going to increase or decrease because of gravity? It's going to increase. So I keep it as a positive. So now I can find how high I was when I dropped that object. Which equation deals with D, V1, A, and T? Which one? One doesn't. There's no distance in one. Are we looking for the velocity or the displacement? Which one are we looking for?
Displacement.
2.
How high above the ground I was? Is that not the question?
Oh, yeah.
But you gotta get, but in 2 you need your V2.
Okay, but in 1,
The third
in
one.
question 1. So, with the third one is this.
Okay, you don't need your V2.
Right? So that gives me how high it was above the ground when I dropped it. Question number 1, right? Is that not right? And then the second part might be, how fast was it moving when it hit the ground? Is that the other part?
I don't think it asked that, it's just one part.
Question.
Okay. So this is the question that was asked. So the second question I would ask you is, how fast was the object moving when it hit the ground? So then, V2, I might be looking for. Well, if I have V1, A, and T, which equation would get me V2? Question 1, or equation 1, sorry, would. Right? So it would be V2 equals V1 plus A delta T. So that question can be done. There can be 2 things asked for it. You're given 3 pieces of information. The essential part of this question is this. The initial speed is if it's in the direction of motion, it stays positive. If that balloon was raising up, you would have a negative velocity there, because it's working against gravity. We okay? All right, so now I'm only asked for this here. Plug in your information. And you can solve the question. Does that make sense to everybody? Any questions about that? That's a question that's a little bit more than what you've already been working on. Okay, that takes you a little bit more because of this part right here and the motion.
So if we were going up first and dropping, and then we were looking negative?
Yeah. Okay? Any other questions? All right, you're good.
Since you're in the air looking at the opposite, your acceleration is 9.8, but if you're on the ground and it goes up, it's negative 9.8.
Or if I was in that balloon and threw it up,
Then it's negative.
then it's negative. But because it starts as a negative and then it turns to a positive. But because we're only working in one direction, and that's down, it's positive, because your speed's gonna increase. Okay? Does that make sense? Okay.
Do we have those questions?
Yeah,
Just a second.